soy profesor en la Escuela de Agronomía, el Centro para Investigaciones en Granos y Semillas, y actualmente director del Instituto de Investigaciones Agrícolas y coordinador del proyecto de seguridad alimentaria, que es el que patrocina esta actividad junto con otras. Now I'm going to switch to English. I want to thank Professor Sudathip Sea-tan for accepting our invitation to come to Costa Rica. And I just want to say a couple of words about her. She has a BS as well as an MSc from Kasetsart University in Thailand and a PhD from the Penn State, and supported by the Thai government. And she did a postdoctoral stay at the State University of New Jersey in Rutgers. And since 2014, she is assistant professor, associate professor at the Kasetsart University. She has several awards. I'm not going to list them all, and her research focuses are food components for disease prevention, dietary bioactive compounds, and molecular biology on these subjects. We have like a car accident close to the university, so we have at least 24 inscribed participants, so I assume that this is because of this car accident that people are going to come later. Okay, the floor is yours, and thanks again for... Sorry?
You want me to start now or wait a little bit?
You can start now and then you can repeat it. You can start now, yeah.
Thank you. Thank you, Rita, for your introduction, and thank you, Professor Rita, for inviting me to the University of Costa Rica. My name is Sudathip Sea-tan, so I'm from Kasetsart University. First of all, let me introduce about my university. So, Kasetsart University, I belong to Faculty of Agroindustry, and I don't know if you know where is Kasetsart University. Do you know where is Thailand? It's right here, a little country right here, under the China. So, the name of my university, Kaset means agriculture and Sart means knowledge. So basically, our university is founded from Kaset agricultural area. And we have 4 main campuses. The main campus is Bangkok, which is located in Bangkok, the capital city of Thailand, and Sriracha, that's on the east of Thailand. Pancreas is also in the central part of Thailand, and Pancreas, that's the northeast of Thailand. But we also building another campuses around the country. We also have 16 research stations around the country and have 5 field stations because we have a lot of agricultural area research. And for the agroindustry department, our code for our faculty is Agroindustry for Life. And first of all, we founded in the Faculty of Agriculture in 1964, and in 1980, the Faculty of Agroindustry was founded, and that's the first founded of our department, Food Science and Technology. So we just celebrated 50 years anniversary 3 years ago. And in our faculty, we have 6 departments. The first one is Agroindustry Technology, Biotechnology, Food Science Technology, Packaging and Material Technology, Product Development. And the last one is Textile and Science. So we teach both management and science related to agriculture, not only food, but also included textile. And the total faculty member, we have 106 faculty members. So for our plan for this short course, so we will have 5 days. For the first day, I introduced my university already, but after that, I would like to know all of you, but maybe we will do it later when we have more participants here. And then I will start with the basic science of nutrition, human body, focus on the digestive system, and finish the first day with the digestion and absorption of the nutrients. On the second day, I will talk about the phytochemicals, part 1, part 2, and we will have the paper to discuss more in the afternoon part. On the third day, I will finish with the phytochemical, the last one, and the principle of pharmacology. The reason that I talk about the principle of pharmacology is because when we study the bioactivity of the components, that will similar to the study on the active compound of the drugs. So that's why I will touch a little bit on the principle of pharmacology. And on the first day, I think we go for the plant. Right?
First day, some farm is very with a growth and range of medicinal plants. So it will be very interesting.
Mm-hmm. Yes. And on the last day, I think this will be the very relaxed day. So first of all, I brought some food from Thailand. So I would like you to try that food. Basically, I want to introduce about that actually our food can be the medicine. Okay, it might not be strong as a normal drug, but we can use this for prevention and mild medicine. And then we will have some presentation. I want you to introduce your own food that you think it might be your own medicine as well. And we will conclude with on the last day.
Can you make insects?
No, of course not. That's not my area. That's going to be Dr. Weeboon. So first of all, let's start about the science of nutrition. So the principle of science nutrition, the first one is food is a basic need for humans. So everyone needs food. We all need food. So do you all have breakfast this morning?
Yes.
Yes, we do. How are others? You all have breakfast? Yes. Why do you think you need breakfast? Sorry if I ask you a lot of questions, but that's my personality that when we teach, I didn't want to talk by myself.
To your life again. You're like it. Like me. You need something.
You need something. And what do you feel if you didn't eat breakfast?
Cranky.
Fatigued?
I feel cranky.
Cranky?
Yes.
Okay.
Yeah, it's tired of yeah, I need to eat.
What is a normal breakfast for Costa Rican?
Coffee.
Coffee.
Coffee, eggs, rice, fruits, learning.
And beans, of course. Yes, I think that's one of the first things that we think about food, that, okay, we need food to energize our body, to make us be able to do anything throughout the whole day. And that's the first one for the food security, that everyone needs to have food. And not only one type of food, we need assortment of food, right? Oh, sorry. And for the second one is food provides energy and calories, nutrients, and other substances needed for growth and health. So maybe that's why you need assortment of food. Do you think having only a cup of coffee, that's enough for your breakfast?
No.
No. Yes, that's why because coffee, okay, is provide you energy, but it's not provide any nutrients, I guess. So that's why you still need eggs, fruits, and bread, and of course beef. Yes. And the first one is health problems related to nutrition originated within cells. So cells can process all the nutrients that you get from your food. Poor nutrition can result from both inadequate and excessive levels of nutrient intake. Not only having not enough food can cause you a health problem, but having too much food and energy can cause you a problem as well, as we know that right now we have a lot of obesity problems throughout the world. Previously, when I was young, there is no obesity problem in Thailand at all. We almost have malnutrition. But right now, maybe 10 years ago, in Thailand, we start having a problem of obesity. How about in Costa Rica? Do you have a problem with obesity?
It's the same trend, I think.
It's the same trend. Do you think why you start having the problem of obesity?
Coca-Cola.
Coca-Cola. mm-hmm.
Fried food.
What?
Fried food.
Fried food.
Fast food.
Mm-hmm. Yes. And that come from the other country or by our original processed food?
I think both.
You think both? Mm-hmm. Yeah. Mm-hmm. I think when previously in Thailand, I talk about Thailand because I have no idea about Costa Rica, how you guys. But in Thailand previously, we don't have much fast food restaurant. And when we go to fast food restaurant, in the point of view of Thai people, that's a high quality food. We don't go much of the fast food restaurant because that's a high quality food, that's expensive food. But when I went to US, it's different perspective. When we go to the fast foods, that's a food for low income people. It's high dense of nutrients and calories, not nutrients. It's high dense of calories, so they can pay $1 or $2 for the whole meal, and that's enough energy for their maybe half day or the whole day. But I think it's different from when you cook at home or you go to a normal restaurant that you get a meal which is consists of carbohydrate, protein, and fat, and also fruit and vegetable, minerals, vitamins. I think that's a different perspective. So I think the problem about obesity is not only what we choose to eat, but it's about the availability of the food around us. So, and the last one, not the last one, the fifth principle is humans have adaptive mechanisms for managing fluctuation in food intake. I think previously in the ancient time, people may not eat 3 times a day. They go hunting in the morning, get some meat. I don't know what kind of meat they're gonna hunt on that day. But at the end of the day, they cook that meat and eat. Maybe they eat only 2 times a day. But right now we change our behavior, that's why. So everyone has an adaptive mechanism. Malnutrition can result from poor diet and from disease states, genetic factor, or combination of these causes. So we all know that malnutrition not only about the food that we eat, but also about our genetic, our history, the family history. If we have to have the high risk of being one certain of disease or not, that's become that result from our family members as well. And also some group of people are at higher risk of becoming inadequately nourished than others. That also related from the genetics. Poor nutrition can influence the development of certain chronic disease. Adequate and balance are key characteristics of healthy diet. Not only having food, but you should have high quality of food that contain all of the nutrients that the body requires. And finally, there are no good or bad food at all. You cannot say that this is the wonderful food that if everyone eat, they're going to be healthy. It might be healthy for someone, but it might not be effective in another person. Okay. For the keywords in the food and nutrition security, the first one is nutrients. Nutrient is a chemical substance in food that are used by the body for growth and health. And for the food security, is the access at all times to a sufficient supply of safe, nutritious food to meet their dietary needs and food preference for active and healthy life. So not only have access to the food, but that food needs to be safe and nutritious. Food insecurity means you have limited or uncertain availability of safe and nutritious food. And finally, the nutrition security not only when you have access to the food, you need to make sure that you have the access to the adequate utilization and absorption of nutrients in the food. That's the keyword for the nutrition security in order to be able to live healthy and active life. So we start at the bottom is we should have a variety of the food, and then people should have access to all that food, be able to utilize that food, and that's result in the food of nutrition status. Food security will play a role in a variety, accessibility, and utilization, but all of these will have the higher impact on the nutrition security. In the household level, the food security will play a role in the food availability and carrying capacity, and including the food intake. But for the nutrition status, that will include other things else, including the health services, environmental condition, and health status that contribute to your nutrition status. So for the 6 categories of nutrition, we all know about these 6 ones. So the first is the carbohydrates, protein, fat, vitamins, mineral, and water. When we talk about nutrients, there are 2 types of nutrients. So the first one is essential nutrients, which is why you think is essential for the body. Why is called an essential nutrient?
Because your body needs them to everything. They're essential.
How about non-essential?
What?
How about non-essential nutrients?
I think essential are because the body can't produce them, so that's why we need to take them from food. And non-essential because the body produces them.
But both of them body needs, but depends on body can produce it or not.
Produce or not, yeah.
Yes, thank you. So the essential nutrients is a body cannot make it, generally produced, you can get it from the diet. You must get it, not make it, you must get it from the diet. And for the non-essential nutrients, yes, it's required for your growth and healthy, but you can get that from the diet. So the essential nutrients including carbohydrate, certain amino acids, essential fatty acids, vitamins, mineral, and water. But for the non-essential nutrients, it's including cholesterol, creatine, glucose. So these things you can get from the food. And yes, everyone needs the nutrients, but are we all need the equal amount of nutrients? Do we need? No, that depends, right? It depends on the age, our age, depends on our body size, gender, genetic traits, growth, illness. If we have fever, if we get sick, we need more nutrients than the healthy people. It depends on lifestyle habits. This morning, I see a lot of people along the way to the university that Costa Rica people tend to exercise in the morning, right? I see a lot of people jogging on the street.
Yeah, it's also a trend now to run, I go to races and everything.
Yeah, so that people need more energy for more than us, right? If we just sit in the office and writing email, manuscript, or doing the research in the lab. This depends on our activities. Smoking and alcohol consumption also affect the energy needs as well. Medication use, pregnancy and lactation. And for the dietary reference intake, the first one I will talk is the recommended dietary allowance. So that is the quantity of the nutrients that is what just that is perfect to have the healthy condition for the healthy people. So this is the refer to the healthy people only, not about the ill people. And for the adequate intake, that's a lower amount that people could take to not get the risk to have certain disease. And for the estimated average requirements is the average requirement that people tend to have and do not have any adverse effects. And this is the upper level that people should not have those nutrients above this level, otherwise it's going to have risk for certain disease as well. So it's showing that, okay, you have certain amount of nutrients, but you cannot have too much that nutrients as well to live healthy. And move very quick to the second part. So the second part will be about the human body, focus on digestive system. So in our body is composed of trillions of cells. The level of organization is cells, many cells combined to be a tissue, a lot of tissue combined as new organs, and many organs combined as organ systems. So each cell is a cell contain living entity. Cells of the same type join together to form tissues, and one or more tissues combine to form organs. Organs are important in nutritional health, and nutritional health determines how the organ functions. So several organs cooperate and form an organ system, for example, the digestive system. When we mention about digestive system, that means we including mouth, esophagus, stomach, pancreas, small intestine, large intestine, liver, gallbladder, and rectum. That's all several organs that contribute to the digestive system. So for the human physiology, constant chemical reaction within the living cells require energy, water, building supplies that mostly contributes from protein and minerals. And finally, all the reaction in the living cells is regulated by vitamins. So this is the digestive system. The first one is mouth and saliva gland. So, and then I will say at the beginning of when you eat the food until the end. So the food starts get into our body by mouth, pass to esophagus, stomach, liver, gallbladder, pancreas. So these two things just secrete the important juice or important digestive juice into the digestive tract. And then the food moves to small intestine, large intestine, and then out of our body through the rectum. The first one is mouth. The mouth will masticate the food. So when we eat food, we chew. That's the mastication of the food. And then the mouth also let us taste the flavor of the food. Without the mouth, you cannot taste anything, right? And also in the mouth, we have saliva that contains solvent inside and mucus that we can chew, we can churn the food within our mouth. For the esophagus, it's a long tube. The length is about 8 inches. It connects the pharynx to the stomach. So it's connected after the pharynx until to the stomach. Yes, you see it's a long tube, but actually it's not a hollow tube. It's not hollow tube. It's made of a lot of muscle that contract to move food to the stomach. The contraction of the muscle called peristalsis. So it will contract and move the food continuously into the stomach. So this is just a cartoon of the peristalsis. So the esophagus will start contraction over here and then move the food mass. Then they start continuous contracting and move the food along the way. So the next one, when the food was moved into the stomach, it will pass to esophageal sphincter. So this is a lower esophageal sphincter which can prevent the food that moves up to the esophagus again. So in our body, we have this muscle that contract and control the movement of the food. The size of the stomach is depend on people, but actually our size of the stomach can increase, can expand. Can anyone guess that how many fold does the stomach can expand when you eat food?
2 times?
More than that.
I don't know.
It's more than 10 times if you eat food. So finally, originally it is very small, maybe to what's it called? Maybe this size. But after you eat the food, you see the wrinkle around here. That can expand the size. So it can expand much more to 10-fold. But it depends. It depends how you train your stomach. If you eat much all the time, your stomach can expand very well. But if you eat food a little bit every day, so your stomach it cannot expand as much as people who eat a lot of food.
That's irreversible, or?
It's reversible, but it takes time. But unfortunately, some people irreversible. So, but in the obesity people, if they get into the very obese, there is a surgery that they can cut the side of the stomach. Because when you cut the side of the stomach, that means when you eat the same amount of food, but the side of the stomach is smaller, they will feel full quickly. That's one way to treat obesity people. So the function of the stomach is like a tank. So they keep the food inside that, but not keep forever. They keep the food as a tank, and they have the digestive juice to digest all the nutrients in the food. And then the stomach also is a place to form calm, which is a mix of juice and food. Because we all have the saliva. In the saliva, we also have the digestive enzyme, but that's a little bit that we have alpha amylase that can digest carbohydrate into the triglyceride or disaccharide or oligosaccharide, but not in monosaccharide. So our body cannot absorb it yet. So, but when it moves into the stomach, it will mix with other digestive enzymes as well. So that's called CAR. In the stomach, we have hydrochloric acid. So the pH in the stomach will be very low, about 2 or 3. And the function of the hydrochloric acid is it will destroy the activity of the proteins, activate digestive enzyme, because digestive enzyme in the stomach will be function at the lower pH. It will be partially digest dietary protein with the enzyme pepsin and chymotrypsin. Assist in calcium absorption and make dietary minerals soluble for absorption. And then the food will move to the small intestine. Approximately, the small intestine will length about 10 feet. That's really long. And I read one article, and they said that in dead body, the length of small intestine is longer when that person alive. I don't know why, but I think that's interesting why when people die, the length of small intestine is longer. Anyone heard about this before? I have no idea either, but I think just, for me, I just think that if people die, the length should be shorter because of the attraction of the muscle. But they just say that it's much longer than the living people. And it's folded wall. Yes, because it's very long, so the wall they fold to decrease the space that they need in our stomach. And at the surface of the small intestine, it has a finger-like structure that's called microvilli. The microvilli can increase the surface area for the absorption. And not only the microvilli, all the microvilli itself, it also has the finger-like structure as well, a little one that's called microvilli. So the surface area in small intestine is very a lot. The microvilli and villi is responsible for the absorb the nutrients, and the cells in small intestine has very rapid turnover, and the movement of my food in small intestine is also using the mechanism called peristalsis as well. Small intestine divided into three parts. The beginning is called duodenum, the middle part called jejunum, and the last part is ileum. The intestinal epithelial cell is a barrier to invading microbes. So in the small intestine, we have some microbes to grow in our small intestine, but it's not much compared to the large intestine. And regulate immune system is also produce the mucus by the mucosal membrane that can help nutrient absorption, and the capacity of epithelial cell in small intestine, it will affect the nutritional deficiency of that person. Because most of the nutrient absorption happens in the small intestine. I will talk about a little bit on the nutrient absorption. So nutrient absorption in our body, there are four parts, four main types. The first one is passive absorption, facilitated. The second is facilitated absorption, and next the active absorption, which is need the energy, and the last one is phagocytosis or pinocytosis. This is the stream of the passive absorption. So the high concentration inside the lumen, that's inside the small intestine, they will use the normal diffusion to pass into the cells. The second one is facilitated absorption. So nutrients need a facilitator to move it. For example, the glucose needs glucose transporter to move from the inside the small intestine into the cells. So the glucose transporter is the facilitator for the glucose. And for the energy use, so some nutrients, they need the energy to push from the intestine into the cell. And the last one is like the phagocyte. So it's like the cell, the membrane of the intestinal eat it. But actually it just fold and keep it into the cell. It will be the vesicle into the cells. That's the four types of the absorption nutrients in the small intestine. And for the large intestine, mostly the food stuff that enter into the large intestine will be the indigestible food stuff, because mostly in the stomach we digest protein and some fat, but in the small intestine we almost digest everything, protein and fat. So everything will be get absorbed in the small intestine. So whatever left over into the large intestine mostly is indigestible. So in large intestine there is no villi or cell or enzyme. So there is no digestion in the large intestine at all. But large intestine also have the mucus producing cells that can generate the mucus that can ease the movement of the foodstuff along the large intestine. In the large intestine is also responsible for the reabsorption of water, some mineral and vitamins. So maybe they have more vitamins and minerals that pass through the small intestine to the large intestine. But those minerals and vitamins will be reabsorbed into our body again. In large intestine, it has a lot of bacteria, including pathogen and good bacteria. Both of them live together, but with the food that we eat in our body, it will dictate if your body gonna have the high amount of good bacteria or high amount of pathogen. if you eat a lot of prebiotics or probiotics, that will increase the amount of the good bacteria, including the lactic acid bacteria and Bifidoflora. When those good bacteria get a higher amount, that will depress the growth of the pathogen inside our body. And so the function of the large intestine is eliminate food stuff that our body cannot digest at all. And final is the rectum. Rectum is the place that stool contain. They have the function to eliminate the stool. So they use the muscle contraction. When you have a lot of stool in the rectum, they will generate the pressure and send a signal to the brain that, okay, you not feel comfortable and you need to get it out those stools. And the movement of the muscle in the rectum that use the anal sphincter. In the rectum also has the function to reabsorb some water as well. So if you didn't get that stool out, as soon as that you get a signal from the brain, the body tries to reabsorb the water more and more. So the stool will get drier and drier. And that affects that when you want to get it off, that stuff, it will get harder. So we also have the accessory organs. I don't know what to call it, I just call it accessory because it's not play the main role, but it is necessary supporting organs that without this organ, the function of digestive tract, it will not properly function. So the first one is the pancreas. The pancreas is behind the liver. This is the pancreas. So it contains 6 types of cells. The major types of cells that we focus on is beta cell. This is the cell that generate insulin, which is the important hormone for the glucose absorption. And gallbladder, that's also right here. And finally, the liver, the biggest organ in our body, play many roles. Liver can secrete the bile acid into the lipid digestion and lipid absorption. Liver also a place to store fat and glucose. Not the main place to store fat, but yes, you have some fat in the liver. However, if you have a lot of fat in the liver will transform to cirrhosis. And finally, it will get the liver cancer. So without the liver, that's going to cause a lot of problems. Even though we call that accessory organ, but we need to pay a lot of attention on the liver. So liver can generate bile acid and is play a role a lot on the enterohepatic circulation because of fat, glucose, and other thing else will circulate in the liver. Liver also generates fat and glucose as well. The pancreas will secrete digestive enzyme, including pepsin, thymosin. It generates a hormone including glucagon and insulin. So insulin will help you to absorb the glucose in the cells. And the pancreatic juice, which is the bicarbonate, because in the stomach the pH is around 2 to 3, but when the food moves to the small intestine, the pH will be increased. So that's why you need a buffer like the bicarbonate. Otherwise, the enzyme will not properly function. Urinary system that contains the kidneys, ureter, bladder, urethra. It will function about the waste product in terms of the liquid products, and it will have the blood acid-base balance. So this is a kidney. Everyone has 2 kidneys, and so this mostly the kidney will be located behind the liver. So to kidney remove waste from the body, it helps to maintain acid-base balance of the blood. It can convert vitamin D to the active hormone. The vitamin D that we get from the sun, it will not function properly in our body, but it needs to be converted into the active form. Otherwise, our body cannot use it. it could produce glucose from amino acid during the fasting. The excess of water, soluble nutrients, and minerals are filtered in the kidney. Urea travels from kidneys to bladder by ureter and bladder empty to urethra. That's the normal function of the kidneys. So in our body also have the storage capacity. Adipose cell is a place to store fat. Mostly the fat that's stored in our abdominal area. The first big piece is called abdominal fat. So if we open our abdominal, if I open my abdominal, the first piece that you're going to see that's called abdominal fat, epididymal fat. So that's the biggest piece of fat in the stomach, in the abdominal area. And muscle liver also store carbohydrate as a glycogen. Normally, when we exercise, the first source of energy that body can use is the free glucose in the blood system. But because we're not gonna have the free glucose for the whole exercise period. So the next place that the body can get the energy from is the glycogen from muscle. And finally, they will get the glycogen from the liver. In the blood, also contain the small reserve of amino acid and glucose, like I said before that. If you just walk, step up on the stair, do a little training, that's the energy from the blood enough. But if we do more exercise, more intense, we need the glycogen reserve energy as a glycogen from the muscle and liver. Many vitamins and minerals are stored in the liver. Calcium can be taken from the bone if needed. However, people may think that getting calcium from the food that's enough, but actually that's not enough for the calcium for the bone structure. Actually, the exercise type that increase the increase of the what's called attack. If you compare exercise between swimming and running. Running we have more contraction compared to the swimming. Running will help your body to generate more calcium bone structure. That's proof already that we need a contraction to help our bone to reform the structure of the calcium and bone matrix compared to the uncontact exercise. So, and finally, protein can be taken from the muscle if needed. But if the protein from the muscle can use for the energy more, the body will get fatigued. And that's why athletes need to get the branched-chain amino acid, because that's the first amino acid that body can use and repair those muscles as soon as possible. So this is a summary of the digestive secretion and their action. The first organ that we talk about is saliva gland. So the target organ for this gland is the mouth. They secrete saliva that its function as, so it will secrete the fluid that is swallowing saliva enzyme to break down carbohydrates, which is the alpha amylase. For the gastric gland, the target organ is the stomach, so they will secrete gastric juice, and this juice will mix with the bolus. Hydrochloric acid can uncoil the protein. So when you get the protein from the food, first of all, they need to denature. And hydrochloric is the first one that can help your body to denature the protein by unfolding the protein. And they also consist of the enzyme that can break down protein, including pepsin, chymotrypsin. Mucus from the gastric juice also protects stomach cell, because in the stomach cell they have the pH very low. For the pancreas, it will secrete pancreatic juice to the small intestine. And the base of the pancreatic juice is a bicarbonate buffer that can neutralize the acidic gastric juice from the stomach, and also contain the alpha-glucosidase, and other lipase that can digest carbohydrate, fat, and protein. Liver will secrete the bile to the gallbladder, and this bile will store until it needed. And then gallbladder secretes the bile from the liver again to the small intestine. And this bile is an emulsifier for fat. Otherwise, the fat is a fat phase, but the juice, the digestive juice, is a water phase. So these two things cannot mix together. So without the bile here, the enzyme in the gastric juice cannot function properly to digest the fat. So that's why we need the bile from the gallbladder and from the liver. So the bile will emulsify fat, so enzyme can attack to the fat and digest it. And finally, the intestinal gland, it will secrete intestinal juice to the small intestine. And intestinal juice, it will consist of the enzyme that can break down carbohydrate, fat, protein fragments, and also including the mucus to protect the intestinal wall. How about we take a break here?
20 minutes. Do you want to take it right now, break?
No, up to you. I can continue.
I mean, because I don't know if coffee is already prepared. Coffee's there.
Am I speak too fast?
10 minutes. 10 minutes.
Any questions so far? Or anything you want me to talk about more before we move to the next topic?
Maybe we can introduce ourselves
Okay.
now.
So my name is Sudathip. I introduce myself again.
My name is Okay, my name is Pancreas, and I work at the Costa laboratory here at the university.
What's your name again? Sorry. Maricruz.
My name is Tanya, and I'm doing my PhD in Germany right now, and I'm dealing with all this bioavailability of nutrients.
Yeah, my name is Dorothy. I'm 26 years old and I'm a nutritionist and dietitian, and yeah, I'm really interested in everything that has to do with food science, technology, food security, so that's why.
So you are PhD student here?
No, just I'm around always.
Okay.
My name is Rafael. I'm here because I'm interested in these topics. I'm getting older.
Hopefully tomorrow topic will be more interesting to you guys. The first day will be basic nutrition. Yes.
My name is Digestion, and I'm a nutritionist, and I'm very interested in these topics. And I work in consulting myself, patient, and I like to know more about this.
My name is Maria Maya. I'm 26 years old. I'm also a nutritionist. I'm very interested in everything that has to do with phytochemicals and nutrients.
I think the first topic is very basic for the participants today. All of you are nutritionists. And I'm not nutritionist. Yes. So, actually, my background is in product development. So for my bachelor degree and master, I developed a new product related to food. On my bachelor degree, the product that I developed is the 5-based bean soup, instant soup. So I made the instant soup from 5 types of beans. And that's my final project. And for my master degree, I developed a product related to food, but not actually food. So I developed the model to predict aflatoxin contamination in the peanut, because in Thailand we use a lot of peanut, and we have a problem of aflatoxin contamination. So I study on the supply chain of the peanut throughout Thailand. So yes, we grow some peanut in Thailand, but mostly the peanut in Thailand is imported from China and the around country of Thailand. So during the transportation, I analyze the aflatoxin contamination and using the software called artificial neural network to predict aflatoxin contamination in the peanut. So that's the product that I developed for my master's degree. And when I moved to my PhD, I study in food science and I study on the effect of green tea, how it can prevent obesity. And I didn't focus on only green tea. Yes, I think we all know that green tea can help obesity, right? But at that time, there is no scientific support that what is the actually mechanism that why green tea can prevent obesity. So that's why I study on this topic. And I also study on the combination effect of green tea and voluntary exercise. Because previously, we know that exercise can help, but when you want to know about the mechanism, how exercise can prevent obesity, mostly in the animal model, they use forced exercise. It's interesting for me, the first time that I see forced exercise is they put the mice into the beaker with water. So when they just release the mice into the water, so the mice is forced to swim. So I think that causes stress to the mice. And yes, there is another application. They show that the level of glucocorticoid hormone is increased in those mice. So that's why I think, okay, I will focus more on the voluntary exercise. So first of all, when I talk to my PI, yes, I focus more on voluntary exercise. And what is voluntary exercise for the mice? We think about the running wheel, and we start questioning if the mice gonna run. We hesitate a lot when we start the study because we worry that the mice not gonna run. Because I think about myself, okay, I like running, but I'm not gonna run every day. But when we attach the running wheel into the case of the mice, we also attach a counter. So we count how many rounds that the running wheel will move. But surprisingly, they run every day, every night. Yes, and they run a lot. They run about almost 2 miles a day. Yes. So they didn't run in the afternoon time or during the daytime. I think they run at night because I check it every morning and I see that they run a lot. Okay, I can say that mice are running.
Oh, I'm sorry.
Yes.
I was just a bit curious about the green tea.
Yes.
So what did you find about it?
I found that green tea can increase the gene expression related to fat metabolism. I can show you the result maybe.
Yeah. It's just that I really don't like it.
You really don't like green
I don't like
tea?
it. I'm like, okay.
You don't like the taste or you don't like what?
It's the taste, yeah. It's too bland.
Too bad. How about green tea latte? If it's blended with milk and sugar and
It has more potential. Yeah, by itself, I don't know.
Coffee is ready, so we can take a break and then.
okay, yes,
And do you drink a lot of green tea
I
in
do.
Thailand?
yes. In Thailand,
Yeah.
for Thai people, no, we don't drink a lot of green tea. Mostly we drink black tea.
Black tea.
Yes. Green tea is just introduced from, we get the influence from Japan maybe 5 or 10 years ago. But Thai people still not only drink plain green tea or plain black tea. We add milk and sugar
Yeah, black tea.
to make it more. Yes.
So why were you interested in green tea? Because you like it or?
Because, first of all, because I like it. Because I like green tea and I know for a long time that green tea can prevent obesity, but there is no research support
Yes.
at that time. So I thought maybe I'm interested in this.
Oh, people is always saying like green tea helps in a lot of things, but there's not proven always.
I
So
think a
it's
lot
really
of
interesting.
ingredients from their traditional remedy, traditional medicine, old people, they know a lot of, how do you say, it's not secret, but it's unproved, but it's active. It can prevent or treat the disease, but it just doesn't have the research support. I think there is a lot of gap that people can study on this area.
Yes, the microphone.